Hey guys, it's Fish Zeus, and today we're going to be solving the famous car problem with acceleration and the city blocks. So first off, let's start off with the diagram. So right here, we have city block 1, or not city block 1, intersection 1, intersection 2, intersection 3, 4, 5, 6, 7, 8, 9, and 10 somewhere over there. Anyways, that's not the point. So anyways, we have the 3 cars right here. Alright, 3 cars right here. So car number 3, car number 2, and car number 1. They're all lined up at intersection 1, all ready to go. Now this right here, this point, is t equals 0. Now, first off, the easiest way to do it, we can find how much time it takes for the first car to get to the next intersection. So t equals something, and that's when car number 1 would be at the next intersection. Then just multiply that by 10, and you get the time it takes for the first car to go through all of those intersections. So, now you have to find out how fast the car is going and how long it's going. So, how long? So the whole thing is 5,000 feet, since each city block equals 500 feet. So now that we have how long it's going, we need to do how fast it's going. So the cars, the maximum speed for the cars is 35 miles per hour. So since the acceleration is measured in 0 to 60 miles per hour, we have to divide that by half-ish and get the actual amount, how much time it gets for the car to go to 35 miles per hour. So for the first car, to 35 mph is 1.46 seconds. Now, at this speed, the first car will go through each intersection in 31.25 seconds for the first car, car 1. Each intersection is 31.25 seconds. Now that does help us, but it doesn't really help us all that much. So, well, at least for now, we can say that this is 31.25 seconds, and that here, when it gets to the next intersection, t equals, well, 62.5 seconds. So that's pretty tight. Now, then from this we can say the time it takes for the first car to go through all intersections is 31.25 seconds, which just multiply the one intersection by 10. Now, that's pretty cool. At least we got a number for the first car to go through all intersections. So we know that the next cars will take a little bit longer. Now let's find out how much longer. So now, to find out how much longer, we need to find out the other accelerations. So of course, 235 equals 1.46 seconds. Because it has the same acceleration. Well, at least it's not exactly the same. It's slightly different, but it's rounded to the same. For simplicity. Car 3 is 1.52 seconds. It's a little bit more than that. It rounds to 2. So now you got all those 3 accelerations. Find the time it takes all cars to go through a light is seconds. To do that, you just add up all these numbers. Now, this is of course an approximation. There's approximations all over the place because you're rounding to make it simpler to understand. Because no one wants to do a lot of complicated math. Even on the calculator, so tiny bit different. Anyway, so that means that when t equals 3, the third car will be leaving the intersection. So probably the second car will be like somewhere like right there. Probably not. But you know what I mean. The first, the second, and the third will always be right behind each other. And the time it takes one of those cars, well actually all of those cars to go through the intersection, is 3 seconds. Now that we have that, we can say, well, since it takes 3 seconds for each car to go, well actually for not each car, now for all the cars to go through the intersection. See, all cars go through the intersection is 3 seconds, and the time it takes for the first car to go through all intersections is 312.5 seconds. We can say that, so you see, the first car going 31.25 seconds later, it hits this next intersection. The third car, though, is only going to be 3 seconds behind. So it takes 3 seconds for the next car to go through that intersection. So, you know, at 34.25, the third car will leave the first intersection. Now, with that in mind, we can say that the time, right here, the big number, the time it takes for all cars to go through all lights is 342.5 seconds. Now, we got that number because we took this, the time each car lags, right here, and multiplied by 10, that's 30, and you add it to the time the first car goes through all intersections to make 342.5. So, you know, the first car goes through 31.25, 62.5, etc., 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 and the third car will be at 34.25 right here, and 65.5 right here, yada yada yada. So in the end, you get the time it takes for all cars to go through all lights is 202.5. Now, that's not exactly what the question was. The question was, how do you time all of that? Basically, what's the time? So, let's imagine this light is red at t equals 0. As soon as the count up starts, so the light turns green, the first car goes from 0 to 35 in 1.46 seconds. So, 1.46 seconds, it goes through, and at 31.25 it hits the next intersection. Now, since the light is still green, the light stays green for 3 seconds because that's the time it takes for all cars to go through the first light. So, the first car goes through the intersection, then 3 seconds later the last car goes through the intersection. And after 31.25 seconds, the first car hits the next intersection. So, this is the first car lights green, and then 3 seconds later, lights red because the third car left. Then 31.25 seconds later, from t equals 31.25, the next light turns green. So the first car is here, the green at 31.25 seconds, green, 34.25, blam, back to red, because the third car just passed through, and on and on and on. For instance, right here, first car, 62.5 seconds green, 65.5, red, blam, next. So in the end, each light stays on for 3 seconds from the moment the first car hits the intersection, and of course, the distance between each intersection will be 31.25 seconds. So of course you can draw a table or just use a diagram to show when each light would turn off and on. And that is all there is about this problem. Thank you very much for watching. This has been Physics Zeus solving the famous car problem. Thank you. Bye-bye.